All right, good morning, everyone. Thought we'd start with a quick update on how our wetlands are doing. Number of acres around the lake is growing and growing and growing, and this is an outstanding thing. 30 years ago, Grand Lake St. Mary's watershed had, around a quarter, certainly less than 0.5% of its watershed area as wetland. Very, very small percentage. Today, that number is right around 2.5% of the watershed is actually wetland habitat. So this is great. Great news, and particularly great news when we look at what these wetlands can actually do for us. They're bringing in all sorts of wildlife habitat. They're bringing in recreational opportunities for us to go out and enjoy the outdoors. But they're also helping to clean up the lake. They're helping to improve water quality. The vast majority of the wetlands in the watershed, as most of you all know, are pump-driven, meaning we're pumping water from the tributaries, from the creeks that flow into the lake, pumping water into these wetlands. That water is flowing through a series of pools and flats that are, vegetated out, and through all sorts of wonderful natural processes. The harmful nutrients that stimulate harmful algal blooms are sequestered by our wetlands. They're trapped in our wetlands. So our wetlands are doing a cleanup duty, almost like kidneys filtering blood in the body. That's what our wetlands do for our watershed. This year, some of our main wetlands, Prairie Creek is moving about 1.5 million gallons a day. Beaver Creek, somewhere around about 500,000 gallons a day. Coldwater Creek, right around 2.5 to 3 million gallons a day, and Burntwood Creek is about 500,000 gallons a day. This is absolutely incredible when you look at the actual flows through the lake, or flows to the lake. For these tributaries at this time of year, this is anywhere from 3/4 to 100% of the actual stream flow that would have made it to the lake. So these wetlands are really moving a lot of water. Draw your attention again to Prairie Creek. That wetland over the last 4 or 5 years has only been able to move about 250,000 to 500,000 gallons a day. There were some improvements done over the past year, and those improvements are extremely visible right now. We've been able to quadruple or even quintuple our pumping capacity, and that's just been phenomenal. We had some improvements to Coldwater Creek as well to update the pumps and repair the pumps from last year. So we are surpassing our flow totals from this time last year. Hopefully, we can keep these things going, and hopefully the vegetation in the wetlands continues to pull out nutrients, and hopefully we can keep these wetlands moving and processing water, ideally all the way into October. So that would be a fantastic thing. When the water gets into our wetlands, you can see some nutrient tables there. And feel free to click around on this online. I'm sure the PowerPoint will be up. You can get a closer view. But in general, these wetlands are removing anywhere from 50 to 75% of the total phosphorus, sometimes above 75% of the dissolved phosphorus, and absolutely above 75% of the nitrogen. And these, phosphorus and nitrogen nutrients are the same ones that if we don't pull them out of the stream, they end up in the lake. And when they end up in the lake, the algal bloom can sort of pick those up and really thrive on those. That algal bloom, as we look at kind of the status of that this year, this week, you can look at this graph. The graph, once again, has got weeks of the year on the x-axis. It's got intensity of the toxin production from the bloom on the y-axis. The big thick line is the historical average. So if you average the last, it's more than a decade now, but if you average the last decade plus, that's the line you get. So that's kind of what we expect to see. That's the average. What we have seen this year is quite a bit lower. In fact, we've been well below that line for every single week this year, with the exception of one little week. And we haven't just been a little bit below the line. If you can look over the last month and a half, we have been deep below that line. In fact, the last month, I believe, we've been at 10 micrograms per liter or less, with a couple of the last weeks being less than 8 micrograms per liter. This water quality data is coming from the middle of the lake, from the Salina Water Treatment Plant. There is some variability when you look around the lake. There's some variability when you compare different beaches and different areas. But in general, it's been an extremely good year for microcystin toxin. If you have been looking at the water and you've noticed, like, well, hey, wait a second, you're saying the microcystin toxins are really great this year, but like I can't see it with my eyes. Like my eyes tell me there's still quite a bit of algae out there. Your eyes are not wrong. There is still quite a bit of algae out there. What I will say on that note is there's a difference between the algae biomass, so how many algal cells there are in the water, and how much toxin they actually produce. This is a Midwestern reservoir. It's a shallow lake that's extremely well mixed, and it's in the watershed it's in. It's always going to have some algae. The goal is to reduce the amount of algae, and certainly the goal is to reduce the toxins. These toxins are the things that can, affect the ecosystem or ourselves negatively, with contact or ingestion of the water. So, the goal is to reduce both, but the toxins are kind of, a number one. When we look at the algal bloom throughout the year, the biomass or the number of algal cells that are out there, that tends to be driven by phosphorus, and the amount of toxins they produce tends to be driven by nitrogen. What we've been seeing this past year is we've seen, fairly large biomass of algae, but it has not been extraordinarily toxic. And that's kind of a consequence of the way the nutrient loading this year has gone. We've had sort of a disproportionate amount of phosphorus in the lake as compared to nitrogen. And so we have a bloom, but it's been, up to this point, quite a bit less in toxicity than past years. So again, this is a good thing. This is a good sign to see. And these toxin numbers, they have seemingly crept down every single year for the last 5-6 years, and that's a great thing to see. And it's not a coincidence that these sort of downticks in toxicity are coinciding with the amount of nutrients that we are keeping in our wetlands and keeping in our best management practices and keeping on our landscapes through some of the great work from our producers in the region, some of our ag producers, and some of their best management practices. So we're keeping a lot more nutrients on the landscape than we would have 10 or 15 years ago. So this is fantastic. In other news, the Lake Restoration hosted the State Directors Tour just a couple of weeks ago, or about a month ago, I guess now. The State Directors Tour involved sharing some of the data from the wetlands and some of the best management practices from the past decade, and kind of giving a massive update to the different state directors. So present at that day were the director of EPA, the director of DNR. We had a variety of state legislators and constituents. We had representatives from the Ohio Department of Agriculture representing the director's office, and a variety of local stakeholders as well from Mercer and Auglaize County. This event included some talks on water quality, some updates, as well as a tour of some of the practices around the lake. A couple of weeks after that, the Mercer County Ag Education Series, in conjunction with the Ohio Wetland Association, hosted a Grand Lake St. Mary's Wetland Tour where people from all over the state of Ohio converged on Grand Lake and had a chance to tour some of the restored wetland projects from around the watershed and really get a look, kind of hands-on. I'm not aware of any other place in the state where, on a square mile by square mile basis, you can find more evidence of habitat restoration. I could be wrong, but again, I'm not aware of any place in Ohio that's done more in a single watershed over the last decade than Grand Lake has. So that's something that we as a local community, we should be proud of and look at that and celebrate that. About a week after that, we hosted a special tour just for the Ohio EPA. So we had more than just the director and some representatives from the EPA. We had the whole Ohio EPA office come, around a dozen or so people came to look at some more of the wetlands in more detail, as well as look at some more of the best management practices around the watershed. And so This summer's been a very productive summer in terms of wetland conservation and wetland conservation research. It's been a productive summer in terms of looking at the toxin data for Grand Lake, and it's been a productive summer in terms of sharing this information. You know, it's one thing for us as a watershed community to do these things, but we should be in a position to share some of our successes, and we should be in a position to share some of our failures, so that other people, you know, this idea of harmful algal blooms and eutrophication, it's not just unique to Grand Lake. It's present all over the United States, and it's present, quite frankly, all over the globe. We are, you know, setting a template for some of the best strategies that are out there to try and conserve our natural resources. And so a lot of these tours and these announcements and bringing people here to our community to sort of share these things, that's what that's all about. It's about getting the word out. You know, hey, this is what we've done, this is what's worked, and hey, this is what we've done, and this definitely didn't work. Please don't try that. And trying to help others as well. So with that, I'll take any questions. All right. Oh, we have a question in the back. Yes, I'm going to repeat your question if that's okay for those online listening. So the question was, when we look at the data from this year, when we look at the algal bloom data, you know, what does that spike actually mean? So when we look at this graphic, we can see the black line, and that signifies the historical average. Again, that average is built by you know, looking at week by week. So week 1 would be January 1st, week 52 would be the last week of December, right? So where we are right now is right around the, you know, the early 30s in terms of the weeks of the year. So we had a couple of spikes. So what do those spikes signify? And those spikes you can see in the historical database. It's not like those spikes were unexpected or unanticipated. So what causes those spikes? You know, what causes those spikes in spring as we transition from spring to summer? And what causes that spike that we're likely going to see in the fall, right? We don't have a crystal ball, so we don't know if we're going to realize that spike or not. But if we look at the historical data set, it would tell us that we're probably going to have a spike of some kind. So what causes those spikes? Those spikes are born out of nutrient loading. You know, the algal bloom thrives on nutrients. It really likes phosphorus to grow in size, and it really likes nitrogen to grow in toxicity. What you're looking at right now is a graphic of toxicity, and so that spike right around week 20, that corresponds with spring runoff. The first part of spring was fairly dry this year. Didn't have a lot of runoff, but the later part of spring we had kind of a disproportionate amount of runoff. We had quite a bit of runoff when we look at the month of April and May. And that's what that is. That's a lot of nutrients getting washed off of the watershed and coming into the lake. And that's phosphorus that built up the biomass. And then unfortunately those spring runoffs also include quite a bit of nitrogen. And that's what we saw as well. When we look at that second spike, that's kind of week 25, that's shortly after another rain event, shortly after a very large precipitation event that caused quite a bit of runoff as well. What's interesting is we've had a couple of big upticks in biomass over the last month. So large concentrations of alga cells have really increased and proliferated over the last month. But what we haven't seen is the toxin data go up along with that biomass. And you know, where does that actually come from? How is that possible? If we look at the sort of nutrient data, the biomass is increasing as a result of phosphorus, which we've had quite a bit of over the last month or so, but we haven't had the corresponding nitrogen. This is what happens when the sediment inside the lake starts to load the water column. This is what's kind of known as legacy phosphorus or internal loading. We have a lot of phosphorus in the sediment of our lake. And that phosphorus for most of the year stays pretty tightly bound to the sediment. It stays put, right where we'd like it, down in the dirt. When we have periods of low dissolved oxygen in the lake that are extremely hot, like we have the last month, during those periods of time, the phosphorus that's locked in the sediment can get up into the water column. And so what we've seen over the last month is we've seen a big uptick in the biomass as a result of that phosphorus load. But that nitrogen is not bound in the phosphorus, or is not bound in the sediment in the same way as phosphorus is. Nitrogen has a slightly different cycle. And so we've seen a big uptick in phosphorus, but not nitrogen. As a result, you can see the algal bloom with your eyes, but when you measure the toxicity, it's just not there. And so, again, this is something that we can't really prevent. We can't change the weather. We can't change Mother Nature. But what we can do is we can take away some of the other nutrients through some of these practices from the external tributary loading. And so as we move forward, I'm optimistic that we can keep this line down. Certainly optimistic we can keep it below the historical average. Every year we see improvements. That dark black line gets lower and lower because it's an average composite of all the years, good and bad. So every year it gets harder and harder to get below that line. Like rounds of limbo, it gets more and more difficult. But every year we get lower and lower. And again, I don't think it's a coincidence that every year we keep piling on more and more conservation practices around the watershed. So,
just a question and a comment. You have the ODNR, you have the Ohio advisory line there. When you had the EPA and the ODNR, here none of whom have been elected in their life, did you discuss that line with them?
yeah, there have been some questions about that line. And that line, it says ODNR advisory on there, but that line is that's suggested by the federal government. That's for the entire state of Ohio. That's not, ODNR didn't set it, but
fact, supposedly based on medical toxicity?
it is based on studies.
Which hasn't been done.
So we have talked about that line, and when they put up the beach signs and things like that, they do it on a site-by-site basis. And so the data you're seeing there comes from, the middle of the water column on one side of the lake, but you might have, Windy Point is a little bit higher, or maybe a little bit lower. There is a little bit of spatial variability in the lake itself. What is extremely encouraging to me is that we can actually have the conversation now where we're talking about these low numbers and talking about, hey, maybe there's a time when those signs could come down, or maybe there's a time where we could really stand behind it and say, hey, this water toxicity is low enough. If we were to wind the clock back 7, 8 years, 10 years ago, certainly, we couldn't have had that conversation. We were so far outside that realm, but now we're close enough to really look at it and say, oh, this is encouraging. There needs to be 2 weeks consecutive, 2 weeks below 8 to take one of those signs down and officially clear the sort of red warning signs from an actual site on Grand Lake. And we have been really close to that margin this year, really close. We haven't quite met it, but it's possible. And the fact that we can say that, it's just incredible. So I appreciate both of the questions about the algal bloom.
I'm still questioning the toxicology
Any other questions? Yes, sir.
Comment with a question.
Yeah, sure.
The last item on Prairie Creek, that I know it has really large with the open main part of the lake, and that seems to be very encouraging.
Yeah. So the comment was when you look at Prairie Creek, right at the mouth of where the Prairie Creek channel kind of meets the lake, you've got the littoral wetland and you got the rock wall right there. But right about where that mouth is, you have an expanding patch of lily pads. I first noticed that lily pad patch a couple of years ago, and then it's just, or maybe even 3 years ago, but every year since then, it's really been expanding. And there's a couple of species of lily pads and aquatic veg that's right there, and that's extremely encouraging. And I'll tell you why. Vegetation in the water needs the same thing that vegetation on land needs. It needs nutrients and it needs sunlight. Nutrients are obviously not an issue here, but sunlight really has been. When you have harmful algal blooms as prolific as what we have experienced in Grand Lake, they tend to use up the photosynthetically active radiation. That's the small portion of the spectrum of radiation from the sun that plants actually use to complete photosynthesis. The majority of that PAR, or photosynthetic active radiation, from the sun. The majority of that gets used up in the first 6 inches of the water column because there's that much algae that just eats and eats and eats. The fact that you're looking at 3, 4, 5 foot of water there and you've got lily pads coming up tells us that that photosynthetic active radiation from the sun is reaching deeper into our water column than it ever has before. And that is incredibly encouraging. And it becomes almost like a snowball rolling down the hill in that, you know, good things beget good things, in that if we have a little bit of aquatic veg there, it's going to take up nutrients and it's going to block out some of that harmful algal bloom. And so something that's a good sign for water quality is going to continue to proliferate and continue to be a good sign. And we could get, you know, more vegetation, you know, in some of those small areas. And it could, you know, hypothetically, if it takes enough nutrients away from the harmful algal bloom, we could see not only the toxicity drop, we could also see the biomass drop precipitously as well. So it's a great comment, great observation. Love to talk about it. Yes? What was that question one more time? Will we actually take the measurements? Like from the wetlands? From the actual lake? Yeah, I can talk about that. So the question was, where do we actually take the measurements? We take them all over the lake, is kind of the short answer. For our wetland data, the 2 big spots we take is the wetland inflow from the stream and then the actual wetland outflow. Very, very easy comparison when you look at that. We also take some samples throughout the middle of the wetland to help us understand where and how the wetland is processing and doing what it's doing. In terms of the toxicity data from the algae, you know, our great friends with ODNR, Dave Fahler in particular, and his staff take water quality data or water samples from a variety of beaches, Sunset Beach, Campground Beach, Windy Point, et cetera, et cetera. The long-term data that I showed, that graphic, that comes from basically the lighthouse in Salina. That's where the Salina water treatment plant intake is. It's real close to that lighthouse. That's where that water quality data comes from. We've got some sampling points kind of right in the middle of the lake. We take a boat out to get samples from as well. So when we give this data, we try to encapsulate as much of the actual system as possible. That way we're not just, you know, reporting news on, you know, the hot water hole, you know, off of the Lakeside Drive there. So yeah, thank you. All right, I think we are moving on. I think we are all very excited to hear about the connection between the Miami and Erie Canal as well as Grand Lake. So I would love to hand the mic over.